Alright, since I did the last video, I've turned the circuit board around so you don't get confused. The antenna is now on this side. The antenna comes in, signal comes in, goes through this switcher. Alright, it gets picked. There's a bypass circuit in here. This is another switch. And then it goes over to the final switch. Alright, now what I did was I put it on a really strong AM broadcast station. I set the frequency for that. And I went over to the final switch that comes off the front end. This is all the front end where the battery pack was. Okay? Putting a piece of wire, in this case it was the tip of a dental probe. I don't know where it's hiding right now, but I held it with my hand and I started going back towards the front, which be the back of the radio, going towards the mixer and all that. So this whole front end is the front end. Okay, this whole area is front end. This is the input antenna, a switching thing. It switches in and out these components. Another switch, then the final switch. So what this does in here is there's a bunch of little ferrite beads. They're tiny. I mean, super tiny. They got different windings on them. So what it does is it pre-selects the front end band-wise. Well, it's only getting FM. So something is wrong just up in this switching section. So I noticed that when I touched this chip here, which is the final of this output, I get the AM station garbled but loud. So I know I'm overloading. We know that station overloads my DX390. So I slowly work my way up back. I'm up at this second switch, and I'll be working my way back. But I started down here at this chip, and this chip is like a mixer, oscillator section. Got up into here, and now it's just a matter of this front end. But you got to remember, only the FM works. None of the other bands work. So it's one of the switching modules, or I'm suspecting that double sticky tape has eaten away at one of the resistors. It seems like there's some type of reaction from the glue to one of these parts. And I don't have the exact schematic. I got the Russian schematic, but I know if I follow the signal back, and in this case, this chip down here is this one, okay? And I came out of the antenna. So in other words, the signal goes in this chip from up here, but I've gotten it to go from here down through the rest of the radio. So my fault is right up in here, okay? So I'll use the same method, leave the radio on the same frequency, and as I go along, that garble should get louder, okay, until it won't go through a component. So one of these parts down here could be one of these two chips. Oh, and as far as the chip not being soldered right from the last video, some of those are unused pins. Okay? I did get that far. But the fault is right in here. Okay? And it can't be one of the ferrite beads because each one of them is used for a different band. So it's a matter of one of these switchers isn't switching correctly. This one allows in AM position the signal from up that should come from up in here. It is going down to this processor. So the fault is right here, and this is extremely tiny. Okay, and like I said, I always tell you, I'll be 60 in a few weeks. 70 in a few weeks. 60. See how senile I'm getting? But I didn't want to be here. Okay, but I have no choice. Like I said, the guy did the last video, the guy isn't answering anymore because I told him exactly what he did. Now this could be a reworked PC board, okay? These are hand soldered. Am I in the frame? Yeah. These are hand soldered. Why is everything else flow soldered in? Has this been worked on before? Does this actually have a problem they couldn't fix, and they sold them off as a special buy? You know, because like I said, a guy bought 10 of these in a store, and they all have various problems with them. So these could be a similar batch, and I might find a component that's wrong from the factory. I might not be able to fix it, but I know right now It's right up in here. Okay, and I'm starting to understand how this works. These are switchers. They switch in and out these different components to create the front end. It is a tuned front end, sort of. And like I said, you got to see how small these ferrite pieces are with wire wrapped around them. They're tiny. They look like a resistor, a surface mount resistor. But if you look close, real close at them, they're the size of a tick, not a deer tick. What's it called? A Lyme disease tick. That's how small these resistors are, and are they coils, and they're wound. They're a piece of ferrite with a bunch of turns on them, and they create a tuned circuit. So the front end of this radio is basically a TRF, tuned radio frequency. Very wide type of radio you could build, but if you take a wide signal and you convert it a couple times, okay, this is basically like a direct conversion radio, but you digitally control it. Slick. It's very slick. You know, I have the information in my head from other things I built, but it would be nice to have the exact schematic. I could be really rolling along. I could be up on this switcher here. It is actually a switch, okay? And oh, the other thing about the switch I want to tell you, for anybody that cares, when it switches off to another position, it shorts out the other positions. So me putting a signal in might not work because the input not only is no longer connected to the output, it shorts the ground. Very slick stuff, okay? But I'm wise to all its tricks at this point. But notice my problem is in the area where this double sticky tape has been. And at first I thought a component was missing here, but I found one of the websites, I actually found a real nice picture of this board, and I can tell that part is missing on that one. And I also can see the inductors, and the guy took such a good picture of this board, I can actually read the part numbers, which really don't do me any good because it doesn't match up with the Russian. The front end is different on this radio, okay? But it does. 85% of this radio is working. That's where we're at now. We're slowly working our way up back, and up in the front, in the schematic, there's a bypass on the front end. So the FM section probably works without using the preamp. So the preamp section, whether you attenuate it or not, is what's used for shortwave and the other frequencies. So that's not working right. So it's right up in here. I really will be unhappy if it goes back to be this double sticky tape has eaten one of the components. Or at one time they put a battery on there, and when they peeled it back off, they broke one of the components. I don't know yet. Okay, and another thing too is we had a job. Oh, what the hell was the name of it? Ads. This company called Ads, and they used to have double sticky tape on the back of the circuit board with a piece of foil on it, and that was to prevent the processor chips from being statically burned out in transit. Well, the guys in the field would put the circuit board into the socket or into the computer, and it wouldn't work, so they sent it back. And you get it. The first thing you do when you check the board when you got it back is to turn it over and look for tape like this. And if you I already put the ohm meter across it. This isn't carbonized, that I can tell. But there is types of tape that's carbonized, and it's to get rid of static electricity. Well, if you put it across a circuit, you could change the biasing. All right, and I don't know if I'm at that level yet, but I'm filing back the signal path using a signal going through my body into the little pin. And I told you many times years ago that before I built this thing, I will not use this on it. This is a signal injector that I designed. It's based on a unit from ICO years ago, and it produces 60-volt spikes, and it goes all the way up from long wave all the way up to short wave all the way up to FM. Okay, but when you press this button, 60-volt spikes come out of here, and you're holding this in your hand, and that's your ground, and there's enough voltage here to burn this out. Okay, that's why I'm not using it. But if I put on the FM, go like this near it, you can hear it. Okay, but that's where we're at for that 1 billionth guy that goes into one of these. And like I told you years ago, I got rid of a lot of my signal generators and my equipment because I used to take a piece of wire and throw it over the top of my fluorescent light in the cellar, and then I'd take that wire and I'd start at the volume control and work my way all the way back up to the antenna input of the car radio, and I'd find the bad part. That's how and everybody's like, what are you doing? I said, I don't need a fancy signal generator. I said, I'm injecting noise. And you go from the volume control and it's really low. You can barely hear like a buzz. And then you go to your, going backwards would be your detector, third IF, second IF, first IF, and then out to the antenna. And that's how I used to fix things. I used to fix things freaking fast. I was young, I was sharp, and I told you, that's why I don't have a life, because I spent most of my life thinking about stuff and repairing things. I think that's it. All right, that's it.